My screen is visible?
Yes, sir.
Yes, sir.
Okay. So yesterday we have seen the starting of a number system. We have started with decimal number system, and we have seen its nines complement and tens complement, and we have also seen how to do subtraction of decimal number using nines complement and tens complement. Then after that we have seen the binary number, and we have just started binary number where we have seen how to convert a binary number to a decimal number. So this we have seen by through an example as well. So let me just give you one quick recap of one such example. Okay, so let us suppose that this is our binary number for which we have to convert it into a decimal. So each place or each digit has its own, you can say, power. So just after decimal, this place is having 2 to the power 0. This is having 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. Similarly, this is 2 to the power minus 1, minus 2, and minus 3. Similarly, you can say I have multiplied by the weight attached to this. 1 is multiplied by 2 to the power 4, this, and 0 is multiplied by this, so on and so forth. And you can then later on calculate by solving, and you can calculate its equivalent digital number, decimal number. Okay. Now we will see decimal. We have seen how to convert binary to decimal. Now we will see decimal to binary. Decimal to binary conversion. So I will directly show you with the help of a problem. Suppose we are having a decimal number of 52. Again, you have to mention the base. You have to convert it into a binary. So how to proceed? All of you might be aware, but I will just tell you. So you have to divide it by a factor of 2. So 52 is divided by factor of 2. So it will be divisible by, I think, 26. And you have to write remainder here, right? Again, 26 you have to divide it by 2, right? And it is divisible by 13. So 2 into 13 will give you 26, and remainder is again 0. Again, you have to divide it by 2 until you are getting the final remainder, which is not divisible by 2. So if you divide it by 2 again, so you will be getting it will be divisible by 6, and the remainder will be, in this case, remainder will be 1. Again, you have to divide it by 2, so it will be divisible by 3, and remainder will be again 0. Again, you have to divide it by 2. It will be divisible by 1, and in this case, remainder will be 1. So now we have reached a state where it is not, we cannot divide it by further 2, right? So in this case, what will be the equivalent digital number? This is the MSB. You can say MSB, most significant bit or most significant digit, whatever you want to call it. This is MSB, and this will be correspond to your LSB or LSD, least significant bit or least significant digit, and you have to proceed in this way. So you have to write, just see the flow: 1 1 0 1 0 0 to the base 2. So this is equivalent to 52 in decimal. Is it okay? This example is okay? Or should I take one more?
Sir, one more.
Yes, sir.
Okay. So let us say that we are having. I will just take a small number. You can generalize it for any other higher number as well. So let us suppose we are taking 49. So let us divide it by 2. 49. It will be divisible by 2 and 4, 24, and remainder will be 1, because 2 into 24 will be 48 plus 1 will give you 49. It will be again divisible by 2. So 1, 2, and in this case remainder will be 0, 2. So it will be divisible by 6 and remainder will be 0, 2. It will be divisible by 3 and remainder will be 0, 2. It will be divisible by 1 and remainder will be 1. Now you cannot further divide 1. So this is the saturation point we have reached. So from here you have to go upward. This will correspond to your most significant digit. This will correspond to your least significant digit, and you have to follow this process, this flow. So 1 1 0 0 0 1 to the base 2 will be equal to 49 to the base 10. I hope that it is clear now. So this is regarding the decimal to binary.
Sir, so we have to divide it only by 2.
Yes, because 2 is the base of the decimal. Any number, if you want to convert from one form to another, the number which you want to get, you have to divide it by that. Suppose if instead of decimal, if you want to convert it into octal, then you have to divide it by 8.
Okay, sir.
So suppose if I'm saying that convert this 49 into a base of octal, right? This base is 8. So in this case, you have to divide it by 8. That will just give you an example, though we will cover it in late. Though we will cover this.
Okay.
So 8 is given by 6, and it is given by it is 8 6 48, and remainder will be 1. In this case, you can see this is our remainder, and it is not further divisible by 8. So this will be the flow. So 49 in decimal will be equal to 61 in octal. So these both numbers are equal, and you can see the base.
16 now.
Sorry.
Okay, yes.
And sir, if in each case the remainder is 0, then we have to write only 0. Yes.
Yes. Correct. If the remainder is 0, you have to write 0. No issues.
Sir, I thought that we have to write each number like 0 0 0 0 0 like this.
I'm not getting. Sorry.
Sir, I thought that we have to write. Sir, like 5 times we received 0 as remainder. So I thought that we have in the bracket we have to write 5 times 0 0 0 0 0 0.
That will not. That will never be the case.
Okay, sir.
Yeah, that will never be the case. And if you find that case, you let me know. Okay.
Okay, sir.
Okay. Now we will see how to convert decimal with a base 10 to equivalent binary. Like you have to convert 0.75, and this is in decimal. You have to convert it into a binary. Okay, so decimal, how to convert it into a binary. So what we have to do, we have to multiply this number after the decimal by 2. 75 multiplied by 2. Just wait a second. So 0.75 multiplied by 2 will be equal to 1.50. Again, what you have to do, you have to take the point after the decimal. So this will be equal to 0.50 multiplied by again 2. So we will be getting as 1.00, which is not further if you again take after the decimal point, that is 0.00, and so it will be 0 again. So you can see now you have to neglect the points after the decimal, and you have to take these points that is before the decimal point, and you have to follow this flow. This, in this case, this will be the MSB, and this will be the LSB. So first will be MSB and last will be LS. First will be the most significant bit, and last, and this will be the last least significant bit. So this will you can write it 0.0575 in base decimal will be equal to 0. Point will be there 11 to the base 2. Okay. Now we will see one more example where we are having both. So you have to convert 105.15 to a binary number. Okay. So here again we have to divide 105 by, you can see we want to convert it into binary, so we have to divide it by 2. So it is divisible by 5, 2. Let me know if I make any mistake. This will be 1. Again divisible by 2. So this will be 26. Remainder is 0. Again divisible by 2. This will be 13. Remainder is 0. 2. 6. Remainder is 1. 2. 3. Remainder is 0. It will be divisible by 2. It will be divisible by 1, and remainder will be 1. And this will be your MSB, and this will be your LSB, and you have to follow this way. So let me write it down. So 1 1 0 1 0 0 1. This is we have converted 105 into decimal. Now we will see 0.15 that we have seen how to convert. So 0.15 multiplied by 2, this will be equal to 0.30. Again we have to take 0.30. 0.30 multiplied by 2, this will be equal to 0.60. Again 0.60 multiplied by 2, this will be equal to 1.20. So 0.20 multiplied by 2 should be equal to 0.40. 0.40 multiplied by 2 will be equal to 0.80. And 0.80 multiplied by 2, this will be equal to 1.60. Now you can stop, because this is your most significant bit in this case. This is the most significant bit, and this is your least significant bit. And in this case, you have to follow downwards, right? So 0.15 in decimal, you can convert it into 0.001001 in binary. So let me.
Sir, why we stop up to 1.60?
See, if it is not mentioned, if it is not mentioned in the problem, then you can write it up to whatever you think is feasible. Suppose if in an example it is given, convert it into 12-bit binary. If bit number is given, then you can take 4 places after decimal. You can take 4 places after decimal. Okay. If bit number is not given, then you can take as much as you want. But 4 or 8, we proceed in the way of either 4 or 8 like this, or 6, right?
Okay, sir.
Yes. If bit number is given, then you have to follow specifically the bit number, so that your whole number can be accommodated or approximated to the best possible way. if a bit number is not mentioned, suppose it might be given in our problem, it might be given that convert 0.015 into 12-bit binary. Then you have to accommodate closest to this number in 12-bit binary, and you can count how many how many digits we have required to convert 105. So this is 1, 2, 3, 4, 5, 6, 7. So you can add one more here, and you can add 0 here, or what you can do, you can accommodate 5 digits here. So the point is that you have to represent 105.15 using 12-bit binary as 12-bit binary only. Okay, so some amount of information will be lost. You can say that since we have stopped here, so 0.60 information is lost in the last repeat, in the last that you have taken. So this is you can consider as to be a disadvantage of digital. When you convert some signal from analog to digital, there will be loss of data. Okay, vice versa is not true. But when you convert some signal from analog to digital, some information might get lost, and we have to approximate that. Okay, so let me write. Yes,
Sir, I
please
have a doubt, sir.
Ask.
Sir, after 1.20 is 0, why you have taken 0.20? Why not 1.20 into 2?
After?
Sir, after it 0.60 into 2, you have taken 0.20. Why not 1.20?
After this step you are asking?
Yes, sir.
It
Yes.
is 1.20. Okay, then?
Then we have taken 0.20 here in the next line.
Yes.
But why we have not taken 1.20?
Because we are converting it into a binary number, and binary number can only be represented by either 1 or 0 or 1. So this corresponds to your binary number. You will write finally this as a binary number. If you have taken 1 here and multiplied it by 2 again, so here it will be 2. So you cannot represent this. Correct?
Okay, sir. Thank you, sir.
So anyhow, you have to represent it in a form of 0 and 1. Right?
Okay, sir.
Okay. So this will be equal to 110. 110 100 1.001 in binary. Okay. So now we have seen how to convert any decimal number to a binary number. Now you can convert any number, any decimal number if you are having, you can convert it into. Same process will be there for octal conversion as well. Suppose if you wanted to convert any decimal number to octal number, then you have to do in that way only, right? You have to make sure that the digit here that you will be using should not be greater than 7. In octal, the highest number is 7. Okay, we will be seeing that. I'm just letting you know for your reference that the pattern will be same in any number system, how to convert from one number system to another. Okay. Now we will see quickly a few examples where you can add binary. This you already know, but I'm just telling for our starting point. So addition of binary number, suppose we are having 1101.101, and if you want to add to 111.011, you want to add this binary number. So you know that 0 plus 0 will be equal to 0, 0 plus 1 will be equal to 1, 1 plus 1 will be equal to 0, and carry 1. This is carry, I can see, and this is sum. And is it okay? This is okay. And if you want to add 1 plus 1 plus 1, so this will be equal to 1 plus 1 will equal to 10, plus 1 will be equal to 1, sum 1, carry 1. Okay. So this is exactly what we are going to do. So 1 plus 1 will be equal to 10, sum is 0, and carry will be gone to here in this place. So here 1 plus 0 plus 1 will be equal to 10 again. So 0, 1 will be gone above. So 1 plus 1 will be equal to 10, that will be 0, and carry will be 1, which will go here. 1 plus 1 will be 10, plus 1 will be equal to 1 1. So here sum will be 1 and carry will be 1. 1 plus 0 plus 1 will be equal to 1 0. So 0, 1 will be gone above. 1 plus 1 will be 1 0 plus 1 will be equal to 1 1. Sum 1 carry 1, 1 will go above. 1 plus 1 will be equal to 1 0 again. Right. Any doubt in this point?
Sir, can you
Yes.
please explain it again?
Okay. So 1 0 1 0 1 decimal 1 0 1, and here it is 1 1 1 dot 0 1 1. I'm just telling you, if you are having 0 plus 0 plus 0, 0 plus 0 plus 1, 0 plus 1 plus 0, 0 plus 1 plus 1, and 1 plus 1 plus 1. So if 0 plus 0 is 0, it will be 0. It will be 1. Here also we will get 1. 1 plus 1 will be equal to 1 plus 1 will be equal to 1 0. If you add 1 plus 1, it will be 1 0, where 0 is the sum and 1 is the carry. Because if you carry 0, that will not make any sense, right? So 1 is the carry and 0 is the sum. So 0 and 1. Like you do in decimal, right? Most significant bit will be the carry and least significant bit will be the sum. Here again 1 plus 1 will be equal to 1 0 and plus 1 will be equal to 1 1. So in 1 1 this is least significant bit and this is most significant bit. So most significant bit will be used as carry and this will be used as sum. So 1 and 1. So similar thing we will see here. Just add 1 plus 1. What it will be? 1 0. So this will be 0 and carry will be 1 here. So 1 plus 1 again 1 0. So 0 will be here and 1 will be gone here. 1 plus 1 will be equal to 1 0. So 0 and 1 will be gone here. 1 now in this case, see this, 1 plus 1 will be equal to 1 0 plus 1 will be equal to 1 1, like in this third case. So 1 plus 1 in 1 the sum will be 1 and carry will be 1. Again 1 plus 0 plus 1, it will be 1 0 0, 1 will be gone above. 1 plus 1 will be equal to 1 0 plus 1 will be equal to 1 1. So 1 will be here and 1 will be here. So 1 plus 1, finally we are having 1 plus 1 will be equal to 1 0. Is it okay?
Yes, sir. Thank you, sir.
Okay. Similarly, we can see subtraction using binary. Subtraction is 1 0 1 0 point 0 1 0 1 1 1 point 1 1 1. Here what you have to do, you have to borrow it, right? So just see from where we can borrow. So you can borrow it from here. So it will be equal to 1 0, and if you give it to here, so this will be 1 0. It will 1 will be remaining, and 1 will be gone here. So it will be 1 1, right? And when it will be 1 1, again it has to give. So 1 1 minus 1 will be equal to, here it will be 1 0, and 1 will be gone here. So here it will be 1. It will be we will be having 1 0. But it has to donate 1, so it will be having 1 as only, and 1 will be gone here. Again, it will become 1 0, but it has to give 1. So 1 0 minus 1 will be equal to 1, and 1 will be gone here. So now it is having 1 1, but it has to give 1 as to the least significant digit. So 1 1 minus 1 will be equal to 1 0 is the remainder here, and here finally we will be having 1 0. If anyone has any doubt, they can ask at any point, right? I have borrowed like you used to be in decimal. I have borrowed in the same way, but here the maximum number can be 1 1. Then we are having 1 0, and then we are having 0 1, and then 0 0. These are the only the possibility. Okay, so if I have borrowed,
Can you explain once again?
okay, I will do that. Okay, just see that we cannot minus 0 and 1, right? So it has to borrow and from where it will borrow, you can borrow it from here as well. But here, if you would have borrowed, then it would have become 0 instead of 1. Then again you have to borrow. So it is again 0. You can see you cannot borrow. So this is again 0. You cannot borrow from here. This is a 1. But if you borrow 1 from here, correct? If you borrow 1 from here, then it will become 0. Then again you have to borrow. Finally, what I will be doing, I will be taking borrow from the MSB here. And if I take borrow from here, right, then this number will become 0, and this number will become 1 0. Okay, because this is the MSB. Like carry was the MSB, so here the one which you are borrowing will be added to the most significant digit, or it will become it will be most significant bit. Now again you have to give from 1 0, you have to give 1 to the next bit. So if you give 1 to the next bit, so from 1 0 it will become 1, and this will become 1 1. But from 1 1 you have to again give it to the next bit. So if you minus 1 1 minus 1, so it will be 1 0, and this digit will be 1 0. Next bit will be 1 0. But from 1 0 you have to again donate and give it to its neighboring bit. So what you will do, 1 0 minus 1, it will be 1, and it will be 1 will be gone here. Again, you can see it has become 1 0, but it has to donate. So you will be donating 1 here, and it will be becoming 1. And we will be having 1 1 here, right? But it has to donate 1, so it will become 1 0, and 1 will be gone here. So finally we will be having 1 0. Is it okay now?
So, sir, we will always start from the left-hand side.
No, you have to analyze by yourself, right? That is what I said. See, if you have borrowed it from here, just this bit, then this bit would have become 0, and 0 minus 1, again you have to borrow it. You can do by side bit as well, right? But in first, it will be better if you can analyze the whole digit at once. The first step is what I have done is I have analyzed. If I would have borrowed from this bit, then this bit would have become 0, and you can see that 0 is again subtracted by 1. So again you have to borrow it, right? This is the same thing. Instead of many steps, what I have done, I have analyzed it, and I have seen that it will be feasible for me if I borrow it directly from this bit. There might be cases you may say that you might not have to borrow it from the least significant bit. Let me give that example as well. Let us suppose we are having, this is just I'm framing my own. Okay, let us suppose we have to subtract this from, let us suppose we have to subtract this. Now see, here you cannot minus it, but when I move to here, and I have analyzed that it is we can borrow this, and we can borrow 1 from here, and it is again it will be subtracted by 0, right? So if I borrow 1 from here, so this bit will become 0, and 1 will be gone here, and this will become 1 0. Now this is feasible for me in this case. So 1 0 minus 1 will be equal to 1, and 0 minus 0 will be equal to 0, and 1 minus 1 will be equal to 0, 1. So this is feasible for me, right? But here in this case, this is in our previous example. If you have borrowed, then you can see that if you have borrowed 1 from the next bit, that is this bit, then this would have become 0. Again you have to borrow it from here, and you can see that this bit is 0, and this bit is already 0, and it has to be subtracted from 1. So any case you have to borrow it, right? You have moved it, I have moved it to here. Again I have seen that this is 0. So anyhow you have to borrow it again. So this bit is 1, but if I donate its 1 to its next bit, then this bit would become 0, and you have to subtract it by 1. So anyhow you have to borrow it. So again this bit is again 0. So the most suitable option for me is to borrow it from the MSB. Are you getting my point? We have analyzed it beforehand.
Sir, so we have to, so the bottom one, we have to eliminate the bottom one.
We have
Sir,
to
our main goal is to eliminate the bottom one, so that no one the number 1 in bottom should not be there after subtracting.
I'm not getting. Can you please repeat?
Sir, you said that in the second example, you have borrowed the one from left hand side, from right hand side, because here we have to terminate this one, this bottom one.
Yeah, obviously, because you have to subtract. Suppose if I'm
Yes,
giving you 99 as a number, sorry, if I'm giving 90 as a number and I say that you subtract 49. So what you
Yes,
will
sir.
do in this
Sir,
case? What you will
we
do?
borrow 9 from there.
Correct. We will borrow 1 from here. Correct.
Sir, 1 or 9, we will borrow 9 from there, sir, I guess.
Why you will borrow 9? If you will borrow 9, then it will become 0.
Okay, sir. Okay, sir.
So you will borrow 1, right?
Okay.
And this will become how much? 10. So 10 minus 9 will be equal to 1. And
Okay,
will,
sir.
8 minus
This
4
1 and 0, they both combine to 10. Okay, sir. Okay.
Okay, are you getting my point? I borrowed
Yes.
1 from 9, na? So similar thing
Okay, sir.
we are seeing here in digital as well. So what I have done, see, if you borrow it from this bit or if you borrow it from here, the thing will be same. What I have done to eliminate complexity, what I have done, I have analyzed it first, and I have seen that it will be very suitable for me if I can borrow the carry, or if I can borrow it from most significant bit. In that way, our solution will be good. So now let us subtract. So 1 0 minus 1 will be equal to how much? 1 0 minus 1 will be 1, right? And again here 1 0 minus 1 will be equal to 1. Here we are having 0. So here we are having 1. Sorry, 1. Here we are having 1. So 1 minus 1 will be equal to 0. Point. Again 1 minus 1 will be equal to 0. Here we are having 1 0. 1 0 minus 1 will be equal to 1. And here we are having 1. So 1 minus 1 will be equal to 0, and we will be having 0. So this will be your how you will divide. How will you subtract? Is it okay?
Excuse me, sir.
Yes, please.
Sir, can you increase the pointer size? Because you are pointing the thing, then it is automatically changing the location, and we are getting confused with that.
1. Let me write it capital, right? 1 0
Sir,
0 0
sir,
1.
text size is okay, sir, but the pointer, you are pointing the things that is making confused.
Sir, the cursor, your cursor.
Cursor, sir, that cursor, yeah.
This cursor.
Yeah, cursor. It is not visible to us. You are pointing the things and saying here and here, and directly you are writing.
it's okay.
At
I-
dot one, sir.
What I will do, I will make a circle, right? So let me do it 1 1 1 point 1 1 1. We have to subtract this. So again, you see 0 cannot be subtracted by 1. If I take borrow from here, it will become 0. But it again, this bit has to take a borrow because it is 1 and this is 0. So you cannot subtract. Again, this is 0. You cannot subtract. If I borrow it from here, again it will become 0. But again, you have to take borrow this. So what I will do, I will take 1 from here, right? So if I take 1 from here,
Excuse me, sir.
yes.
Sir, that means we can only subtract when there's 1 at the top and 0 at the bottom, right?
Sorry, can you please? You can only subtract.
When there's 1 at the top and 0 at the bottom, means from that point. At the top example also, we were able to subtract only when there was 1 at the top and 0 at the bottom.
If you're having 1 1 and you have to subtract this, so it will be 0. If you're having 1 0, then it will be, if you subtract, then it will be 1. If you're having 0 1, then you have to borrow.
Okay, sir. Okay, sir.
Which case you are asking? Is your doubt is clear?
Yes, sir. Yes, sir. I understood. I
Okay.
was just trying to understand some pattern.
Okay. So if you borrow 1 from here, so this will become 1 0, correct? But again, it has to give 1. So if you minus 1 from this one, so this will become 1, and 1 will be gone here, right? So this bit will become 1 1. But again, it has to donate. So 1 1 minus 1 will be equal to 1 0, and 1 will be gone here. So this bit will become 1 0, but again it has to donate. So 1 0 minus 1 will be equal to 1. 1 will be remaining, and 1 will be gone here. So this bit will be 1 0. Again it has to donate. So this 1 0 will become 1, and 1 will be gone here. So this will become 1 1. But again, it has to donate, so this will become 1 0. Have I made any mistake? Okay, 1 0 and 1 will be gone here. So this will be 1 0. Finally, we are having 1 0. Now see how I am subtracting. So this 1 0 minus 1. If you subtract 1 0 from 1, the remainder will be 1. Again, 1 0 minus 1, the remainder will be 1. 1 minus 1, the remainder will be 0. Dot. 1 minus 1, the remainder will be 0. 1 0 minus 1, remainder will be 1. 1 minus 1, the remainder will be 0. And here it was 0 because we have borrowed 1, so it will be 0. Now is it clear?
Yes, sir.
Okay. Any doubt? If any doubt, you can ask me. Okay, now we will see next, that is signed binary numbers. Signed binary numbers, that means binary number with a sign. In digital, that is you can say in digital machines, you cannot represent negative sign, right? You can never see such kind of digital representation because this cannot be represented in digital computers or digital machines. So in order to accommodate this minus sign, what we will be doing, we will be using signed binary number. We will sign each binary number so that by looking at the binary number, we will be able to classify whether it is positive number or negative number. Till now, if you can remember, we have only seen positive number as an example. But you know that there are decimal number as well. So how your computer will store the decimal number? So in order to accommodate that, what we will be doing, we will be using signed binary number so that we can accommodate negative sign as well or a negative number as well. Okay. In a signed binary number, there are two forms. Two ways you can represent. First is sign magnitude, and second is complement form. In sign magnitude, what you will be using? You will be using 1 bit to represent sign of that number. Let us suppose if there is 1, so you assign 1 as negative number and you assign 0 as positive number. We will see an example. I'm just giving you for a brief. So we will use one of the bit of the binary number to represent, because we have fixed if the number is, if the digit specific digit is 1, that means the number is negative. If the digit is 0, the number is positive. The purpose of that digit is only to represent the sign, right? It will not count in the magnitude. So you can see there are two words, sign and magnitude. So 1 bit we will be using as sign and rest of the bit we will be using as magnitude. Complement form, we have seen 1 as complement for digital for decimal we have seen 9 as complement and 10 as complement. Similarly in binary we are having 1s and 2s complement. So we will be seeing that what is complement form and what is sign magnitude shortly, right? So there are two forms in which we can represent the sign binary number. First one is sign magnitude, then complement form. These two are there. So we will see one by one. So I'm saying mostly subtraction is performed by 2's complement method in binary. I'm talking about, now we will only talk about binary. Mostly subtraction is performed by 2's complement method. Now you see, I will tell you one thing, that as far as addition is there is no issues, right? Now in order to reduce the hardware that we have that is there in your system, so what computers do, they never perform subtraction, right? They never perform direct subtraction like we have seen in here, like we have seen this case. So the computer do not directly perform the subtraction. What they will do, they will compute the 2's complement of the sub. We will see as an example again, and then they will add, like we have subtracted using 9's complement, right? So similarly, same thing will be followed for binary as well. So you can say that subtraction is performed by addition. In digital, subtraction is performed by digital, by addition, and how we are calculating the subtraction of binary, we will shortly see. Just for now, remember this point that in computer, subtraction is never happens. We perform subtraction by addition itself, by taking 2's and 2's complement or 1's complement. There are methods which the computer, or there are logics which the computer uses to perform the subtraction. For addition, there is no problem, because if you want to perform direct subtraction, then again you have to add the hardware part, right? And the complexity and cost will increase. So your prime motive is to reduce the complexity and reduce the cost. So this is the prime motive of any, you can say, engineer. So what is available at present, you have to make it a better, whatever is present in present world, in order to you have to make that machine a better in terms of performance as well as cost and size. So this is where engineering comes in, right? Okay, so this is just a fact that I have told you. Mostly subtraction is performed by 2's complement. You can perform it by 1's complement, we will shortly see. And addition is there in your digital, but subtraction is never there. So subtraction we will do by using addition, and how it is done we will see. Okay. So now we will see sign magnitude form that we have started. Sign magnitude form. Here, as I've told you, suppose we are having a binary number. I have taken randomly, I have taken one binary number, and it is equivalent of 41 in decimal, right? Now, if I say that this number is positive 41, then in MSB, this is the way of representation. There is no hard and fast. This is the way of representation. If we are having positive number, then we will add 0, right? And this MSB represents the sign bit. 0 means positive number, and 1 means negative number. 0 means positive number and 1 means negative number. So this whole as a binary number will be there, and it will be informed to you that this binary number is in sign magnitude form. So when you see this binary number and you know that this representation is in sign magnitude form, now you will be able to specify or classify that since there is 0 in MSB, so this must be a positive binary. So this would be a positive number. Now what you will do, you will again follow the same step that we have seen in our previous form, how to convert the binary to decimal, right? So this is a positive number. Similarly, if you would have wanted a negative 41, so instead of 0, you would have written 1, and rest of the bits are same. So you can see here, this is sign bit. This is quite simple, I guess. So in MSB, I have altered between 0 and 1 to get positive and negative number. So in your computer, if you enter -41, your information will be stored, if it is stored in sign magnitude form, right? There are many ways of representation. Sign magnitude form is one form. So if you type in your laptop -41, so this information will be stored in this format. And every time if you want to recall, it will be recalled in this way only. Here, yes.
So if we wanted to write -8, so, so will the binary be 1001? Sorry, 10, 100, 100.
You can represent -8 by this, and minus sign is there, so 1 will be here.
Sir, but how will the computer know that that is the most significant bit? So because we will be assigning according to the bit that we are using in the computer, right? It's like a 8-bit computer or 16-bit computer.
Okay, so you are saying that so in this way, if you want to represent -8, then you would have used 8-bit.
Sir, so that means we will be writing 1 as the 8th bit at the starting, and then zeros, and followed by the 8 number that we want.
See, if you want to represent -8, then there is a you can say a special case in 2's complement. So we will see shortly this how can we store -8. Okay.
Okay, sir.
Okay, we will see shortly how can we store this -8. This is a special case where we will use 2's complement to represent -8. Okay, this is a special case. Other than this, any doubt?
So the same thing, like if we remove that 1, like that was 41, right? And instead of 41, if I want to represent -9, so we will be removing that 1, 2, 3, 4, 5, the 7th bit. So this so from the 7th bit.
If you want to represent what?
So if I want to represent -9,
-9.
so it will be 1, 0, 1, 0, 0, 1.
1001. This is for 9, and if you want to represent minus, it will be one sign ahead. 101 is the form of -9, correct? And 1 will be added in front so that it will be -1.
Okay, sir.
Okay, and there are other forms as well. We will shortly see. So first, what you have to do, you have to convert whatever the number is there. You have to convert it into a binary, and depending upon what is the sign, whether it is 0, whether it is positive or negative, then you have to add 0 and 1 accordingly. If it is a positive number, then you have to add 0 at the MSB. If there is a negative number, then you have to add -1 at the negative. Okay, and what the questions you have asked, we will see this shortly. This is a special case, and we will see how we can represent this number. Okay, is it okay?
Yes, sir.
Okay. So now we will see representation. Sign magnitude form we have seen. Now we will see representation of sign number. Representation of sign number using 2's complement form and 1's complement form. How we can represent signed number using 2's complement and 1's complement form. So if number is positive, it is represented in true binary form, and sign bit 0 is placed in front of MSB, most significant bit. So what does it mean? If the number is positive, then no need to change anything. It will be represented in true binary form. You can say true binary form, and you have to place 0 like we have seen in sign magnitude form. Then you can place 0 in front of it, and it will be representing a sign binary number. Second case, if number is negative, then representation, then it is represented in 2's complement or 1's complement form, and bit 1 is placed in front of MSB. If the number is negative, then it is represented in 2's and 1's complement form. We will see how we can do how we can calculate 2's complement and 1's complement, and you can place 1 in front of MSB. And how to take 1's complement? Suppose if you are having a digital number, a binary number 1010 like this is if you are having the binary number, and if you want to calculate its 1's complement. So 1's complement you can easily calculate by replacing 1 by 0 and 0 by 1. So this is replaced by 0. This will be replaced by 1. This will be replaced by 0, 1, 0, 0, 1. Simple. So this is the 1's complement form of this number. And if you want to calculate 2's complement of the same number, you have to add 1 to the 1's complement. So if you are adding 1, so 1 plus 1 will be 1, 0. So 0 will be here, 1 will be 1 here. So 1, 0, rest will be same. So this will be the 2's complement representation of the binary number. So 1's complement and 2's complement is clear, I guess. For calculating 1's complement, you have to do nothing but change 1 and 0, interchange 1 and 0. And for calculating 2's complement, you have to add 1 to the 1's complement so that the resultant will be 2's complement. Okay, now let us suppose we want to represent number 51. Let us suppose we want to represent. Yes.
Excuse me, sir.
Yes, yes.
So there is the next class. Please take attendance.
Okay, okay. It's time. Okay.
So 9:57. 9:57. Sir.
So we will stop here. Be here. I will be joining this meeting again because somehow the attendance is not showing. Just wait for a second.